Hi, my name is Tahir, and this is the video for our Project 2 circuit analysis. So, yeah, let's get started. So, let me explain to you the logic behind the code. So, what we're trying to do is this circuit right here. Using Kirchhoff's law, what we want to do is get a set of equations, mainly three equations, and use these three equations to solve for I1, I2, and I3. So, how are we going to do that? So, the best way is using Kirchhoff's law to create a system of linear equations. Using these equations, we use MATLAB to solve these equations, and solving these equations will give us the solution for I1, I2, and I3. Why would it give us I1, I2, and I3? Because this is the current we want to find, and we are given V1, R1, and R3, V2, and R3. So the basic logic is this right here is loop 1, and this right here is loop 2. What's happening is there is a current from going from the positive terminal, goes to R1, then splits up over here. That is I3 is equal to I1 plus I2. That's why, because the current is splitting up over here. Same is happening for V2. Let's name this loop 1. Let's name this loop 2. So the equation for loop 1 is negative V1 plus I1 R1 plus I3 R3 is equal to 0. And the equation for this loop, which is loop 2, is negative I3 R3 negative I2 R2 plus V2 is equal to 0. And the general equation, which is governing all of them, is I3 is equal to I1 plus I2, since the current splits in loop 2. So what is the algorithm that we have used for the code? Let's see that. So housekeeping commands. So first of all, we call the function vr. Now this function vr contains v1, v2, r1, r2, and r3. Then we call the function circuit solver. I will explain to you in a minute what the function circuit solver does, but this function basically solves for I1, I2, and I3. Now this is task 2 right here. Make a random voltage value ranging from 0 to 500, which goes in increments of 0.1. Using that, we find the minimum and maximum voltage in that vector by restricting the current between 0 and 1 ampere. For task 3, we call the function circuit solver again, but this time we are varying the resistance between 15 to 115 ohms, and hence we get different values for V2. And this, we plot the resistance and voltage values using plot. So what did I mean by task 3 there? Let me just turn this off. um, right here, as we vary R3, V2 will also be varied. So that's what task 3 is basically. So that's the algorithm and the logic. Let's see the code in action. So right here, as you can see, we call the VR function. Now let's open the VR function file, and you can see V1 is defined, V2 is defined, R1, R2, and R3 is defined. Let's run section. So let's ignore all this. So let's use pause for that. Right here. All right. So basically, at the beginning of the code, we have only these values. We only have these three values and these two values. After we call the function circuit solver, it calculates these three values right here. So this is I1, I2, and I3. So let's see the function circuit solver. Now there are two ways of solving for I1, I2, and I3. One is using the function solve, which involves using a system of two equations and then using this solve. And another one is using Cramer's rule. So what Cramer's rule actually is that R1 and R3 share a common coefficient, and R3 shares another common coefficient. Let's say this is X, which is I1, this is Y, which is I2, again I1 and I2, and this is the solution solve, which is equal to V1 and V2. What we do is we find the determinant of this, and then let's say the determinant is, like, let's say this is the determinant, for example. What we want to do is we want to replace this with the solution and then operate upon these two, then this with the solution and operate upon these two. Using that logic, that's what I've used over here. We get dval, and dval of 1 is I1, dval of 2 is I2, and dval of 3 is I3. So that's basically what circuit solver does. This line right here is used in task 3, which I will explain when we reach task 3. So right here we define I1, I2, and I3 in order to save time, and this is task 2 right now. We're at task 2. We've completed task 1. So task 2 right here is we're restricting the value of I1 between 0 and 1, and if this condition is true at any point in which we're going through this vector, it's going to save that value. And this value is basically the voltage value, and we want the minimum of that and the maximum of that, and this is plotted on this graph right here: minimum maximum, and the average voltage is also given. Now this was task 2. Let's go on to task 3. Now task 3 is fairly simple to understand. What you want to do is we want to vary this R3 value between 15 and 115, keeping everything else constant. You want to see how V2 varies. That's pretty simple and intuitive. We use a for loop, and we put this R3 right here. So that's why we had an extra input. And now we use the extra output, which was not used in task 1 right here. Right here. We didn't use that extra output, but we use it over here to get the new value for V2. So if I do V2 val 1, V2 val 1, you can see it's one value. But if I were to say V2 underscore new 1, you can see it's a vector. And from this, we want the minimum and maximum of V2 underscore new 1, of V2 new 1. Now basically what we do is R3, which is from 15 to 115, and V2 new 1, which I just showed you, we plot this on this graph, and as you can see, it's a linear relationship right here. And this is the equation of this trend line, which has been fitted, and the slope of this would be the current, because V equals IR, so V by R is equal to I. Let's now see if it works for this other VR1 file. Run section, and this is, oh, I'm sorry, I forgot to remove the pause. There we go. It works, and see the slope has changed, hence the function works. Let's test it out one more time. Run section. Alright, as you can see, the slope has changed again, so we can conclude that the code works. Now let's get on to the limitations. The only limitations I can think of is this code will work for any values for I1, I2, V1, R1, R2, and R3, and it will give you I1, I2, and I3. But the problem is if you were to change the circuit even slightly bit, or let's say you add another loop right here, or you remove this loop and it's only this loop, MATLAB won't know that, because it wouldn't be called hard coding, but basically this code will work only for this circuit right here. It won't work for any other circuits. So yeah, that's the only limitation I can think of. Another one is I don't know, if you enter a negative I1, negative I2, negative but a positive I3, and the current directions are not the same, the answer will be coming out to be correct sometimes, not correct the other times, because the negative positive signs will be contradicting. Now the application is, let's say some electric firm designs a similar circuit to this. If they want to check the math behind it, all they gotta do is go to VR2, whatever they want, input that value, run section, and there we go. MATLAB gives you everything, like literally everything. It gives you a graph as well, with the minimum and maximum plotted on the graph using the text function. So yeah, that's the end of the video. Thank you for watching.